Hello everyone, welcome to this tutorial by Zebra Code. In this tutorial, we are going to learn how to work with inline namespaces in C++. C++ inline namespaces, what are they? An inline namespace is a namespace that uses the optional keyword inline in its namespace definition. The optional keyword inline is added to it or omitted when defining it. The inline namespaces were first introduced in C++ 11. Inline namespaces are not actually namespaces, as everything that is declared inside of them is also part of the parent namespace. Members of an inline namespace are treated as if they are members of the namespace they are enclosed in. Inline namespaces can be used for versioning, for example, API versioning. Inline namespaces are very useful. For example, if you care much about API backward compatibility, you can provide old and new versions side by side. Here are some facts about C++ inline namespaces. In my previous videos, I mentioned the importance of closing the curly brackets appropriately. But with inline namespaces, the closing curly brackets are applied differently from that of nested namespaces. The inline namespaces is a transitive property. What that means is, for example, if a namespace operating system contains an inline namespace, Windows operating system, which further contains an inline namespace, Mac operating system, and then it further contains an inline namespace, Linux operating system. In that case, the members of Linux operating system can be used as if they were members of Mac operating system, Windows operating system, or operating system. This is as a result of the fact that it is a transitive property. Now, with this said, we can actually look at some code and see how inline namespaces work in C++. But before we do that, kindly subscribe to this channel if you have not already done so. Now, let's write some code to see how inline namespaces work in C++. To do that, open your favorite code editor, anyone will do, but in my case, I will be using the Sublime Text 3 code editor. I have created a folder and I named my folder namespace_inline. You can name yours the same or give it a different name. Inside this folder, I will create a file. And I am going to name my file as app1.cpp. It is a .cpp file. Hit enter. Now, I'm going to enter some code. First, I will add some header files. I'm going to add some header directives. Include iostream, include string, int, main, return 0, semicolon. There is nothing special with this code at the moment. It's just a normal C++ main file. Save it. Now I am going to add a namespace and I will call it study. That will be namespace study. I will add a comment here. Normal namespace. Normal namespace. Here I'm going to add a function I will call it education, void education. This is a function inside the normal namespace. We'll say here function inside normal namespace. I will add a comment here, end of normal namespace. Now I am going to add another namespace here with the keyword inline added to it. It will be inline namespace, and I will call it employment. I will also add a function here, and I will name it full-time. That will be void full-time. Here I will add a comment, end of inline namespace. Save it. So here we have two namespaces. One is named study, the other one named employment. But look at them carefully. They are separate namespaces. They are not nested. This one is on its own, and this one is on its own. Now let's try to access them. If I say here study, education, that's okay. It works. If I say employment, full-time, that's okay. It works. Now, if I say education, this will throw an error. Error, no such function. Education was not declared in this scope. Education was not declared in this scope. If we call the education function, we will get this error message. Error, no such function. Education was not declared in this scope. However, if we call the full-time function, that will be okay. Works. So to test our code, let's compile and run it, or we save it. Now I am going to open CMD and navigate to where the file is. Command prompt, CMD. It is on my desktop. This is the path, CD desktop, and CD my intro, and CD namespace underscore inline. That's my file. And we hit enter. G++ -O for output, run app1 app1.cpp. Hit enter. Exactly. Here now we have this error message. Education was not declared in this scope. Error, no such function. We actually have the function. Now let's comment out this line that is causing the error message. The call to this function education is the cause of that error message. Now let's comment it out and run our code again. Save. Once again, let's compile and run it. Exactly. Now it was compiled successfully, no error message. So if you look at it carefully, this may not make much sense, We could even have done it with nested namespaces. We could have added this namespace to this one, that is nest the namespaces. But there are some use cases where it will make sense. For example, that can be in the case of API versioning. This example was to introduce you to the use of inline namespace in C++. Now we are going to look at another example which will give us the chance to look at it as a way of versioning APIs. I am going to create another file for the second example. New, I will name this one app2.cpp. Okay, now here is a situation. I will paste the text for the situation here. I have pasted here now the text that I typed up before to explain the situation. Assuming we have written a library with a login details class. We are later not happy with it and we want to make changes to it in another version release for improvements. Not all users will upgrade immediately. We release a new version. Some will still want to continue with the old version, while some will be using the new version. But we want both group of users to be able to use our library. To address that issue, this could be a possible approach to the problem by using inline namespaces. I'm going to enter some code here, some header files first. Include IOStream, include string int main return 0. Now let's add some namespaces. First I'll say namespace zebra code underscore library. I'm going to create a class here, class login details public login details constructor. Let's add a destructor to it. Login details destructor std string first name semicolon std string last name semicolon std string say password semicolon. We can save it, fix that. Now this login details class has these features for first name, last name, password. These attributes are part of the class. Now we are going to modify our API so that it takes another attribute, it adds another feature to it for fingerprint. To do that, we can use inline namespaces for versioning. In that case, here I will add a namespace. You can say here namespace version underscore 1. Let me move this one to the bottom. Yes, so that closes it there. I'll add a comment here. Would login details class. And we can copy everything here. Just to save time, copy everything. I'll paste it right here. Then make changes. Call this one namespace version 2. You can add inline to that one. Inline namespace version 2. This will now be new login details class. And here we are going to add Another feature, say bold fingerprint. New feature added to this version. Now we add a more comment here. Note that the login details is not in Zebra code library directly. The closing methods for nested namespaces is not followed here. So new login details class with improvements. Note that the login details class is not in Zebra code library directly. The closing methods for nested namespaces is not followed in here. All right, now let's see what we have got here so far. Here now we have namespace version 1 with this login details class in it and these features. It has here 3 features. And here we have an inline namespace version 2, the same class login details. Now it has 4 features. One new feature has been added to it, which is for fingerprint. We want to add fingerprint login feature in the new version. Unfortunately, the new login details class is not a backward compatible, and some users will still have to use the old version. They may not want to upgrade straight away when this feature is added to it in our new version. So to ease a transition and accommodate both the old and new users, we have to come up with a product that is upgradeable. And in this case, a lot of users will be using the login details class that is compatible with them. Now, I'm going to add some comment here. Some users will be using Zebra code library : version 1 : login details, while some will be using Zebra code _ library version 2 : login details. I'm going to comment them out. I'm not going to run this code. The version you are using will be decided by what you want to use, and you can easily change between them. So this was to demonstrate to you a possible scenario where we could use inline namespace for API versioning. The topic of namespace is a big topic in C++, and namespaces are being improved in newer versions of C++. For example, the C++ 20 has improved on the nested namespaces declaration of C++ 17. I hope you learned something from this video on the topic of inline namespaces in C++. If you like this video, give it a thumbs up, subscribe to our channel. Bye for now.